A kerosene lamp is a type of lighting device that uses kerosene as a fuel. Kerosene lamps have a wick or mantle as light source, protected by a glass chimney or globe. Lamps may be used on a table, or handheld lanterns may be used for portable lighting. Like oil lamps, they are useful for lighting without electricity, such as in regions without rural electrification, in electrified areas during power outages, at campsites, and on boats. There are three types of kerosene lamp: flat wick, central draft, and mantle lamp. Kerosene lanterns meant for portable use have a flat wick and are made in dead flame, hot blast, and cold blast variants. Pressurized kerosene lamps have a gas generator and gas mantle. These are known as Petromax, Tilly lamps, or Coleman lamps, among other manufacturers. They produce more light per unit of fuel than wick-type lamps, but are more complex and expensive in construction, and more complex to operate. A hand pump pressurizes air, which forces liquid fuel from a reservoir into a gas generator. Vapor from the gas generator burns, heating a mantle to incandescence and also providing heat to the gas generator. The first description of a simple lamp using crude mineral oil was provided by al-Razi in 9th century Baghdad, who referred to it as the nafata in his Kitab al-Azra. In 1846 Abraham Pineo Gesner invented a substitute for whale oil for lighting, distilled from coal. Later made from petroleum, kerosene became a popular lighting fuel. Modern versions of the kerosene lamp were later constructed by the Polish inventor Ignacy Angstrom Kasierich in 1853 Lviv. Kerosene lamps are widely used for lighting in rural areas of Africa and Asia where electricity is not distributed, or is too costly. Kerosene lamps consume an estimated 77 billion liters of fuel per year, equivalent to 1.3 million barrels of oil per day, comparable to annual U.S. jet fuel consumption of 76 billion liters per year. Flat-wick lamp: a flat-wick lamp is a simple type of kerosene lamp, which burns kerosene drawn up through a wick by capillary action. If this type of lamp is broken, it can easily start a fire. A flat-wick lamp has a fuel tank, with the lamp burner attached. Attached to the fuel tank, 4 prongs hold the glass chimney, which acts to prevent the flame from being blown out and enhances a thermally induced draft. The glass chimney needs a throat, or slight constriction, to create the proper draft for complete combustion of the fuel. The draft carries more air past the flame, helping to produce a smokeless light which is brighter than an open flame would produce. The lamp burner has a flat wick, usually made of cotton. The lower part of the wick dips into the fount and absorbs the kerosene. The top part of the wick extends out of the wick tube of the lamp burner, which includes a wick adjustment mechanism. Adjusting how much of the wick extends above the wick tube controls the flame. The wick tube surrounds the wick, and ensures that the correct amount of air reaches the lamp burner. Adjustment is usually done by means of a small knob operating a creek, which is a toothed, metal sprocket bearing against the wick. If the wick is too high, and extends beyond the burner cone at the top of the wick tube, the lamp will produce smoke and soot. When the lamp is lit, the kerosene that the wick has absorbed burns and produces a clear, bright, yellow flame. As the kerosene burns, capillary action in the wick draws more kerosene up from the fuel tank. All kerosene flat-wick lamps use the dead flame burner design, where the flame is fed cold air from below and hot air exits above. Central draft lamp. A central draft lamp, or Argand lamp, works in the same manner as the flat-wick lamp. The burner is equipped with a tall glass chimney, of around 12 inches tall or taller, to provide of the powerful draft this lamp requires to burn properly. The burner uses a wick, usually made of cotton, that is made of a wide, flat wick rolled into a tube, the seam of which is then stitched together to form the complete wick. The tubular wick is then mounted into a carrier, which is some form of a toothed rack that engages into the gears of the wick-raising mechanism of the burner and allows the wick to be raised and lowered. The wick rides in between the inner and outer wick tubes. The inner wick tube provides the central draft, or draft that supplies air to the flame spreader. When the lamp is lit, the central draft tube supplies air to the flame spreader that spreads out the flame into a ring of fire and allows the lamp to burn cleanly. Mantle lamp. A variation on the central draft lamp is the mantle lamp. The mantle is a roughly pear-shaped mesh made of fabric placed over the burner. The mantle typically contains thorium or other rare earth salts. On first use, the cloth burns away and the rare earth salts are converted to oxides, leaving a very fragile structure which incandesces upon exposure to the heat of the burner flame. Mantle lamps are considerably brighter than flat or round wick lamps, produce a whiter light and generate more heat. Mantle lamps typically use fuel faster than a flat wick lamp, but slower than a center draft round wick, as they depend on a small flame heating a mantle, rather than having all the light coming from the flame itself. Mantle lamps are nearly always bright enough to benefit from a lampshade, and a few mantle lamps may be enough to heat a small building in cold weather. Mantle lamps, because of the higher temperature at which they operate, do not produce much odor, except when first lit or extinguished. Like flat and round wick lamps, they can be adjusted for brightness. However, caution must be used, because if set too high, the lamp chimney and the mantle can become covered with black areas of soot. A lamp set too high will burn off its soot harmlessly if quickly turned down, but if not caught soon enough, the soot itself can ignite and a runaway lamp condition can result. One popular model of mantle lamp uses only a wick and is unpressurized. Pressurized mantle lamps contain a gas generator and require preheating the generator before lighting. An air pump is used to deliver fuel under pressure to the gas generator. Large fixed pressurized kerosene mantle lamps were used in lighthouse beacons for navigation of ships, brighter and with lower fuel consumption than oil lamps used before. Kerosene lantern. A kerosene lantern, also known as a barn lantern, or hurricane lantern, is a flat wick lamp made for portable and outdoor use. They are made of soldered or crimped together sheet metal stampings, with tin-plated sheet steel being the most common material, followed by brass and copper. There are three types: dead flame, hot blast, and cold blast. Both hot blast and cold blast designs are called tubular lanterns and are safer than dead flame lamps, as tipping over a tubular lantern cuts off the oxygen flow to the burner and will extinguish the flame within seconds. Dead flame equals, the earliest portable kerosene glass globe lanterns, of the 1850s and 60s, were of the dead flame type, meaning that it had an open wick, but the airflow to the flame was strictly controlled in an upward motion by a combination of vents at the bottom of the burner and an open-top chimney. This had the effect of removing side-to-side drafts and thus significantly reducing or even eliminating the flickering that can occur with an exposed flame. Later lanterns such as the hot blast and cold blast lanterns took this airflow control even further by partially enclosing the wick in a deflector, or burner cone, and channeling the airflow through that restricted area, creating a brighter and even more stable flame. Hot blast equals, the hot blast design, also known as a tubular lantern due to the metal tubes used in its construction, was invented by John Irwin and patented on January 12, 1868. The hot blast design collected hot air from above the globe and fed it through metal side tubes to the burner, to make the flame burn brighter. Cold blast equals, the cold blast design is similar to the hot blast, except that cold fresh air is drawn in from around the top of the globe and is then fed through the metal side tubes to the flame, making it burn brighter. This design produces a brighter light than the hot blast design, because the fresh air that is fed to the flame has plenty of oxygen to support the combustion process. Fuels. Generic lamp oil is available clear or in a choice of several colors and in scented and unscented forms. Although more expensive, lamp oil is highly refined and burns more cleanly and with less odor than kerosene. The lamp oil must not be liquid paraffin. Water-clear K1 kerosene is the next grade of preferred fuel for kerosene wick lamps. In some locations they sell red kerosene, which is dyed red and is slightly less expensive than K1 kerosene, as no motor fuel taxes are collected on it. Red dyed kerosene is not recommended as the dye will gradually clog the lantern wick, causing odor and reduced performance. Clean Heat brand is another highly refined fuel cleaner burning, nicer smelling kerosene substitute, sold at many hardware stores during winter. Citronella oil is a citronella scented lamp oil. Some brands also have lemongrass oil in them and they are used for their insect repellent properties. Citronella and lemongrass fuels should only be used outdoors. Liquid paraffin-based lamp oil should only be used in flat wick lamps with a wick diameter of less than 5/8. Used in larger wicks and the wicks become clogged and must be discarded. Flat wick kerosene wick lamps should only be operated with kerosene, lamp oil or clean heat, but alternative fuels are used in an emergency. Such fuels may produce additional smoke and odor and may not be usable indoors. Tractor vaporizing oil is made from kerosene with some additive to make a motor fuel for tractors. Number 1 diesel fuel is about the same as kerosene but with the additives to make it a motor fuel. Jet engine fuel is essentially kerosene with a few additives. Round wick, center draft lamps, must only burn either clean heat, or low-odor mineral spirits. Any liquid with a low flash point presents a high risk of fire or explosion if used in a kerosene wick lamp. Such liquids are dangerous and should not be used in a kerosene lamp or lantern. Examples include charcoal lighter fluid, gasoline, naphtha, white gas or Coleman fuel, mineral spirits, paint thinner, white spirit, other hydrocarbon solvents such as turpentine, benzene, xylene, toluene, acetone, camphor, lacquer thinner, denatured alcohol. Contamination of lamp fuel with even a small amount of gasoline results in a lower flash point and higher vapor pressure for the fuel, with potentially dangerous consequences. Vapors from spilled fuel may ignite. Vapor trapped above liquid fuel may lead to excess pressure and fires. Kerosene lamps are still extensively used in areas without electrical lighting. The cost and dangers of combustion lighting are a continuing concern in many countries. Performance: flat wick type lamps have the lowest light output, center draft round wick lamps have 3 to 4 times the output of flat wick lamps and pressurized lamps have higher output yet. The range is from 8 to 100 lumens. A kerosene lamp producing 37 lumens for 4 hours per day will consume about 3 liters of kerosene per month. See also. References. External links: International Guild of Lamp Researchers, Making and Repairing Kerosene Lamps, Information Concerning Kerosene Burners by Gerard Bruder, Oil Lamp Basics for Survivalists, Information on Diets Kerosene Lamps and Lanterns, The Kerosene Lamp BAT 158, How to Assemble a Kerosene Lamp, Antique Lamp Supply, Information on Blinking Kerosene Lamps.